Hello everyone, this is Introduction to Mathematical Economics prepared to Dr. Nozita binti Jamil. Let's go. And this is me. My name is Rose Pilamina Clement Jivanathan with the metric number 287323 from Group A, course Bachelor of Science Economics from Semester 1. And here is the agenda in the video. Here we are having three parts, which is the first part we are going to look at concavity. Follow up with the second part, we are going to look marginal cost and interpretation, and lastly we are going to look revenue, cost and profit function. Let's go for first part, concavity. Here is the question. Determine where the function fx equals to x cubed minus 6x squared plus 18x minus 15 is concave upward and where it is concave downward. And here is the solution. The first step what we should do is differentiate by using the power rule. By the function given, we need to identify first and second derivative function. Here is the first derivative function. We will get fx equals to 3x minus 12x plus 18, and the second derivative function we will get 6x minus 12. And the second step is we need to find the interval. If the second derivative is equal to 0, x value will get 2. So the interval will be negative infinity to 2 and 2 to infinity. And the third step is we need to identify where the concave upward or concave downward by test number in the interval. We need to have 5 columns with stated interval, follow up with the test number, value of second derivative, sign, and last column for concavity. If the interval we are using is negative infinity to 2, the test number we are using is negative 1. By substitute the value into the second derivative function, we will get the answer is negative 18 and the sign will be negative, and we know that concavity is less than 0. If we use the interval is 2 to infinity, the test number we are using is 3. By insert the value into the second derivative function, we will get the answer is 6 and the sign will be positive and concavity is greater than 0. Step 4 is we need to determine concave upward or concave downward. If the interval is negative infinity to 2, the concavity is less than 0. If the interval is 2 to infinity, the concavity is greater than 0. So from here we can conclude that if the second derivative function is greater than 0, f is concave upward for that interval. Inversely, if the second derivative is less than 0, f is concave downward for that interval. Let's go for second part, which is marginal cost and interpretation. And here is the question. Suppose that the cost function for a manufacturer is given by Cx equals to 0.00001 x cubed minus 0.003 x squared plus 5x plus 1000. Describe the behavior of the marginal cost function. And here is the first question. We need to find the marginal cost function. Follow up with the second question is we need to describe the behavior of the marginal cost function, whether concave upward or concave downward. Prove your answer. For the first question, we need to find the marginal cost function, and here is the steps. We need to define the derivative of Cx, and we will get that 0.00003 x squared minus 0.006 x plus 5, and this is the marginal cost function. For the second question, we need to describe the behavior of the marginal cost function, whether concave upward or concave downward. Prove your answer. And here is the steps. We need to find the second derivative marginal cost function and the interval to identify concavity by using the power rule. So we will get the second derivative of marginal cost function is 0.00006x minus 0.006. To identify a concavity, the second derivative of marginal cost function equals to 0 and the x value we will get is 1000. So the interval will be negative infinity to 1000 and 1000 to infinity. And here is the next step. We need to identify where the concave upward or concave downward. We need to state the 5 columns, which is start with interval, follow up with the second column with the test number and value of the second derivative, sign, and last column is for concavity. If we are using the interval is negative infinity to 1000, the test number we are using is 500. By substitute the value into the second derivative of the cost function, we will get the result is negative 3 over 1000 and the sign will be negative, and we know that concavity is less than 0. If the interval we are using is 1000 to infinity, the test number we are using is 2000. By insert the value into the marginal cost function second derivative, we will get the positive answer, which is 3 over 500, and we know that concavity is greater than 0. So from here we can conclude that if second derivative is greater than 0, f is concave upward for that interval. Inversely, if the second derivative is less than 0, f is concave downward for that interval. So lastly, we are going to look last part, which is revenue, cost and a profit function. And here is the question. A company has established that the revenue function in Ringgit Malaysia is Rx equals to 2x cubed plus 40x squared plus 8x, and the cost function in Ringgit Malaysia is Cx equals to 3x cubed plus 19x squared plus 80x minus 800. And here is the first question. We need to find the level of production that will yield a maximum profit for the company. And the second question is we need to find the price per unit to maximize the profit. Let's go. And here is the first step. We need to find the profit function. How to find the profit function? Revenue function minus with cost function, and we will get profit function, which is negative x cubed plus 21x squared minus 72x plus 800. And second step is we need to find the first derivative of profit function by using power rule, and we will get negative 3x squared plus 42x minus 72. So the third step is we need to find the level of production, which is x. If first derivative of profit function equals to 0, the x value will be 2 and 12. And to find the exact unit that maximum profit, the fourth step we need to find is the second derivative profit function. So we will get negative 6x plus 42. And to last one is we need to know this is maximum or minimum or an inflection. We need to check it by using the second order conditions. By using the second derivative of profit function, we need to substitute the x value, which is 2, and we will get 30, which is greater than 0. If we are using x equals to 12, the value we will get is negative 30, which is less than 0. And here we'll know that 30 is the minimum and negative 30 is the maximum. So from here we know that the level of production that will yield a maximum profit for the company is 12. And last question is we need to find the price per unit to maximize the profit. When the level of production is 12, we need to substitute the value into the profit function to get the answer. So we will get 1232. To find price per unit, we need to divide it with the level of production, which is 12, and we will get the price for per unit. So the answer is 102 ringgit 67 cents. And we know that price per unit to maximize profit is 102 ringgit 67 cents. That's all. Thank you for watching.